Hello folks, I wanted to do a couple problems from the contingency table that we were discussing earlier, and so I wanted to clear up a few things that wasn't aligning with some of the theory things that we were studying. All right, first of all, a contingency table is a two-way frequency table, and it's dependent on a couple of categories. So I decided to pick the category of being in Redwood City versus not in Redwood City, and then I decided on the category of being 19 and under or over 19 years old. And then we got this from the survey that I collected. And then what we did was to find out, we found out the total number of students who said that they were from Redwood City, and there was 11 of them. And then we sorted it so that we saw all the Redwood City folks. And out of all the Redwood City folks, how many of them were 19 and under? We counted that, and we got 5. And then we deduced from there that this number that's Redwood City and over 19 is going to be 6. Okay. So we found some basic probabilities. If we selected one student out of the whole thing, how many of them would be in Redwood City? That would be 11 out of 22. And how many of them would be not in Redwood City? Remember, there's a prime notation here, the apostrophe, also known as prime. RWC prime would be not in Redwood City, and that is going to be a total of 11 out of 22. Okay, and then under 19 and under, and then over 19, we got those to be these numbers over 22 as well. Okay, now we took a look at the addition, or the something and something, and then something or something, and I want to just go over these things with a little bit more care. And before we do that, though, let us realize that to use the and, the addition or the multiplication rule, we have to make sure that the data that we're looking at is not independent. And that was, I think, my error here, and that's why this formula is incorrect, because I assumed that they were not independent, but they actually are. Those two things. And so if they're not independent, then there's something in this probability. So let's take a look at these two probabilities. So the probability here is asking us that we select a person who is 19 and under, given that they live in Redwood City. So let's assume that they live in Redwood City, and what's the probability that they are 19 and under? Okay, so we ask ourselves how many people in live in Redwood City, and there's 11 of them, and how many of them are 19 and under, and there's 5. So realistically, this answer should have been 5 people who are 19 and under, given that they actually live in Redwood City, and that's 11 people that live in Redwood City. So you're not looking at the grand total here, because you're asking this condition that they actually live in Redwood City, and there's only 11 of them. Okay, so that's 5 out of 11. If we turn this around and say, what's the probability that somebody lives in Redwood City given that they're 19 and under? So this time we would be looking at, given that they're 19 and under, there's 12 of them. Oops. What's the probability that those 12 people are 19 and under? What's the probability that out of those 12 people, we select somebody who lives in Redwood City? So that would be 5 over 12. Okay, so that's 5 over 12. And the 12 comes from the total number of people who live, who are 19 and under. And then the 5 would be the 5 people who are 19 and under and live in Redwood City. Okay, so those are our probabilities. So now when we come to this question here, what's the probability that somebody is 19 and under and lives in Redwood City, or vice versa? Then we say it's going to be the probability that somebody lives in Redwood City times the probability that they are 19 and under, given that they live in Redwood City. Okay. So what is this? This turns out to be, what's the probability that somebody lives in Redwood City? That's 22 out of 11. Or I'm sorry, 11 out of 22. And then we're going to multiply this by the probability that somebody's 19 and under, given that they live in Redwood City. We computed that already. That's 5 out of 11. All right. When we cancel all this stuff out, we see that the 11 and the 11 would cancel because one's in the numerator, this is in the denominator, and we just get 5 out of 22. And that is your answer. Now, the shorter way of doing this is that if you're looking for this probability in the table, what's the probability that we select somebody who lives in Redwood City and is 19 years or and under out of the whole thing? So if we pick one person out of the total who lives in Redwood City and is 19 and under, and that's going to be a total of 5 divided by 22. And so that's exactly the same answer over here. So instead of having to do all this work, if you have a contingency table, the and would just be finding something in the body of the table, and then you're dividing by the grand total, which is 22. Okay? All right, so I will cross this one out because that was not correct, and the not correct part was this business over here, and now we just corrected it. If we were to do this the different way, we should still get the same result, because this is an and so if we say probability of getting something that's getting somebody who's 19 and under, and then we're going to multiply this by the probability that somebody lives in Redwood City, given that they're 19 and under. So let's find those things because, oops, this is given. And let's find those probabilities because we have them here already. So 19 and under is 12 out of 22. And we're going to multiply that by the probability somebody lives in Redwood City and 19 and under, so that's 5 over 12. Oops. Let's get the 12. And then that is equal to, if we cancel the 22s or the 12 and the 12, that's 5 over 22 again. By the way, this should equal to the same thing, right? Well, let's take out our calculator. I had some misgivings about this calculator, but I think I figured it out. 5 divided by 22 equals, and that's 0.2273, which is the answer that they got here. Okay, so that is the addition rule. Now let's do the, I'm sorry, that was the multiplication rule. Let's do the addition rule with the OR this time. So this is an OR. So what's the probability of somebody being in Redwood City and all that stuff? So let's add this up together. This is going to be, according to the addition rule, it's going to be the probability of somebody's in Redwood City plus the probability of somebody's 19 and under minus the probability of somebody's in Redwood City or 19 and under. So that will give us the probability of somebody in Redwood City was 11 over 22. And then we're going to add the probability that somebody was 19 and under. That's 12 over 22. And then we're going to subtract the probability of the and we calculated that already. That's 5 out of 22. And so here we're just adding, oops, sorry, this is a subtraction. Let's see if they're going to give us the answer. There it goes, is equal to this number. Now, another way to do that using the table is that you're calculating all these things, and each of them will have a denominator of 22. So another way to do this problem is to count the number of people in Redwood City. Oh, I'm sorry, the number of people in Redwood City, that's 11 over here. So that's going to be 11. And I'm going to put parentheses because this is all going to be in the numerator. And then the number of people that are 19 and under. So number of people 19 and under, that's 12. But when we're doing this, we're kind of counting this. We're counting 5 plus 6 to get 11. And we're counting 5 plus 7 to get 12. And if you notice that we actually counted this twice, so this is what we want to subtract out. So we're going to subtract out the 5. And then we'll divide the whole thing by 22. So that should give us the same result as we had last time. And here, as a matter of fact, it did. So that's the addition rule. That's the OR part of this. Okay, so I hope that helps dealing with the contingency table. And I do want to make a point that the contingency table, if there are non-zero values in any of the body of the table here, then they're both going to be not independent. So they're both going to be dependent and not mutually exclusive. So this thing here will always come into play when doing the multiplication rule, the conditional probability. And then you're always going to have to subtract out an and because you're going to eventually count something twice. All right, I hope that helps. Good luck.